Hello, this is Matt from Matt Heaney Apps, and welcome to the 12th and final part in our series covering all the basics of Swift 3. In this video, we will continue our look at classes, and we will take a look at inheritance. This video carries on from the last video, and we will build upon our playground from last time where we built our person class. So if you want to work along with this video, make sure you've seen the previous video. So let's jump straight back into Xcode. Okay, so back into Xcode and back into our playground from the previous video. As a quick bit of recap, here we have a class for a person. This class has three properties, a name, an age, and a country. We have our initializer, and we have a method to celebrate birthday. We have two people, we have Sarah and Jay, both of type person. And then we used person1 and person2 to see what we could do with classes. What we will do is delete this stuff down here. So all that we have is our class and we have our two people, both Sarah and Jay, both of type person. And this here will be our starting point for this video. So please make sure you have this from the previous video. So in this video, we will build upon what we know about classes and we will look at inheritance. With inheritance, we can make a brand new class, so a brand new custom type for a brand new object, item, or thing. And with inheritance, this new class can build upon what we already have in another class. So as always, that will make sense with an example. So far, we have a person class, so we could make a person in our app or in our game. That's all well and good, that's working fine. However, in this pretend app we're making, not only do we want a person, we want another class. And this class will be for a YouTuber, so someone who makes videos here on YouTube. And we want to do this as a different class to person, because obviously not every person is going to be a YouTuber, so we want to keep our person class for anyone who isn't a YouTuber. So I've just got back into making these YouTube videos, so I thought that would be a good example. So let's make our class. We know our keyword class, YouTuber, with our curly brackets. So we now have our brand new class, YouTuber. So what would someone need to be a YouTuber? Well, they would need a channel name, they would need a number of subscribers, and they would need a number of views. So just the total number of views for all of their videos. So a YouTuber would have properties for their channel name, their number of subscribers, and their number of views. These are three important things that make up a YouTuber. However, a YouTuber is still a person. So on top of everything they need that makes them a YouTuber, they need all the things that make them a person. So I make YouTube videos, I'm sure a lot of you make YouTube videos. We all have channel names, we all have a number of subscribers, and we all have a number of views. But we're still a person, we still need a name, an age, and a country. So basically, for YouTuber, we need everything a person has with a few extra bits. So you might be thinking, let's just grab all of this from our person class, let's copy it and throw it into YouTuber, and now we can build upon this. Because yeah, that would work. But this should hopefully be making alarm bells sound, because we don't want to be copying code. Copying code is a bad way of doing anything, so we don't want to do that. However, we do need all of that stuff. So what we can do, when we set up our YouTuber class, we can inherit from person by saying class YouTuber : person. And just by doing this, everything a person has, a YouTuber now has. YouTuber is a new class, so a new custom type, a new object, and without doing anything, YouTuber has everything that a person has. We can now build upon this by giving YouTuber everything a YouTuber needs to be a YouTuber, and in addition to all of these new properties, they all have everything that a person has. So we inherit when there's a is a relationship. A YouTuber is a person. A YouTuber needs everything person has, but a few more bits. So already, YouTuber has properties for name, age, and country, because they inherit these down from the person class. And it also has the methods. It has celebrate birthday. But now we can build upon this without affecting person in any way. So let's have a look at this. What does a YouTuber need to be a YouTuber? Well, like we said, we would need a property for channel name. So this is in the YouTuber class, which would be a string. We'd have number of subscribers of type int and number of views, again, of type int. So now any variable or any constant that is of type YouTuber, they have a channel name property, they have a number of subscribers property, and they have a number of views property. But in addition to this, because this class inherits from person, they also have a name property, an age property, and a country property. Because if they are a YouTuber, they're still a person. They still need the things that make them a person. So by inheriting from person, we make a new relationship between these two classes. And because YouTuber inherits from person, the person class becomes the super class of YouTuber, and YouTuber becomes a subclass of person. So, because we inherit from person, person is what is called the superclass of YouTuber, and YouTuber becomes a subclass of person. So we have our inheritance, let's make a YouTuber, and we will really see this in action. So we know with classes, we have to initialize this. So we'll have our init method, and we know we need a channel name, we need a number of subscribers, and we need a number of views. These are the values that our YouTuber needs when we make a new YouTuber. And then all we have to do is take these and set them to our properties, right? So self.channelName equals channel name, self.number of subscribers equals number of subscribers, and self.number of views equals number of views. We've now taken our values that we passed in when we make a YouTuber, and we've set these to our properties. Job done, right? Not quite, because we still have an error. And this is telling us that we haven't set up super in it. So what does that mean? So we know a YouTuber needs these three properties. However, we also know a YouTuber is a person. So if they're a person, that means a YouTuber must also have a name, an age, and a country, because these are what a person needs to be a person, but nowhere are we giving this YouTuber a name, an age, and a country. They're quite important. You know, my channel is Matt Heaney Apps. I have my number of subscribers, I have my number of views, but I'm still Matt24 from the UK, and they're quite important. So, when we make a YouTuber, in addition to these, we also need values for the properties that a person needs. So here, we're also going to ask for a name, an age, and a country. So now, when we make a YouTuber, we have all of the things that a YouTuber needs to be a YouTuber, and we have all of the things that a person needs to be a person. Because a YouTuber, fundamentally, is still a person. So how do we use these values, these parameters, to take care of a YouTuber still being a person? Well, as you may remember, person is the super class of YouTuber because we inherit from person. So this is the super class. So here in the YouTuber initializer, because we're inheriting, we also have to run a super initializer, which will initialize the super class, which in this case means we will initialize the person class, and effectively all we're doing there is setting values to the properties that a person needs to be a person. So with a super initializer, we can give the name property a value, the age property a value, and the country property a value. And to do that, we do it through a super initializer, which effectively will just run the initializer from the person class to take care of these properties that we have inherited. So we have to initialize the super class. We have to initialize person. So we will say inside the initializer super. As you can see, that is person. So take the super class and we will initialize this dot init. And this here is our initializer from the person class. See how it all links in? All we're doing is setting up what the YouTuber needs to be a YouTuber and then taking care of making them a person in a super class. And now here we can just pass in name, age, and country are parameters. Now note how we don't have to use self or anything like that here. This could look pretty confusing, but our code knows exactly what this means. These here are the parameter names from the initializer method from the person class. So it knows what these are straight away, and it knows what the values we are passing in are, because if we don't use self or anything like that, and there are parameters in this method of these names, so name, age and country, it will assume we mean the parameters. So here it knows exactly what we mean. And our code understands that what we're passing in here into the super initializer, which is just the initializer from the person class, are the parameters that we passed into this initializer. So now we have set up a new class for YouTuber. YouTuber inherits from person because anyone who is a YouTuber still is a person. So all we're doing is taking everything they would get from being a person and adding to this to make them a YouTuber. That means anything that has this type, so anyone who is a YouTuber, has these 3 properties and all of the properties in person. They will have 6 properties. These 3, the 3 that make them a YouTuber, and the 3 from person, the 3 that make them a person. Because they need all of these, when we initialize a new YouTuber, we ask for everything they need to become a YouTuber and everything they need to become a person. We initialize this class, and then once that's taken care of, we can initialize them as a person by running a super initializer, which will initialize the super class, which is person because we inherit from person. So here we take care of what they need to be a person. We take care of their name, their age, and their country. And for a class that inherits, that's it. So let's check this out. So how will we make a YouTuber? Well, outside of the class, it is very similar to just making a person. Var YouTuber1 of type YouTuber, our new custom type, our new class equals YouTuber. And now it's going to ask us for all of the properties that make them a YouTuber and then a person. So let's set someone up. So let's pass some values in. So channel name, Matt Heaney Apps. Should totally subscribe to Matt Heaney Apps, by the way. Number of subscribers, we'll just say 20. Number of views, we will say 300. So now we've taken care of making me into a YouTuber, but because a YouTuber is still a person, we now have to set up the things that make me a person. Because even though I have Matt Heaney Apps, I have my subscribers, I have my views, I'm still just Matt 24 from the UK. So now we have a YouTuber. And this YouTuber, so YouTuber1, has all the properties that make them into a YouTuber and all the properties that make them a person. And we did not have to include these properties in the YouTuber class because we inherit from person, so we get all of these properties and these methods that were in person in YouTuber. So YouTuber1, and now we can do channel name, Matt Heaney Apps. We could do number of subscribers, so the things that make someone a YouTuber, but we can also do the things that make them a person. .name, .age, and .country. So with inheritance, we can take an existing class and build upon this to make a new object that expands upon this starting class without affecting the starting class in any way. So person has not changed at all. We've just built upon person for YouTuber. So a YouTuber can do anything a person can do, but a person who isn't a YouTuber can't do the things that a YouTuber would do because they don't have these extra properties. We've just built upon person with these for anyone who is a YouTuber. So for example, person 1, who as you may remember is Sarah. Sarah's not a YouTuber, she's just of type person. So Sarah doesn't have a channel name. If you went up to someone who doesn't make YouTube videos and asked them what their YouTube channel name was, they would give you a weird look and they couldn't give you an answer. Okay, don't have a channel? And that's effectively what our code's doing. Person 1 doesn't have a property for channel name because person 1 does not have these properties. We have not affected person in any way, we've just built upon this for anyone who is of type YouTuber. Now in addition to the properties, the same thing works with methods. So YouTuber1 can run celebrate birthday because a person can celebrate a birthday and a YouTuber is still a person. So as you can see, happy birthday Matt. However, we can build upon this with a new method in YouTuber. So back into our YouTuber class, we will say func, and something that a YouTuber could do, they could gain a new subscriber. And here we will simply add 1 to number of subscribers, and we will print yay new subscriber for your channel, and then the channel name. So we can run this on any variable or any constant that is a YouTuber. So what we could do, YouTuber1, which remember is of type YouTuber, not only can they do the things that a person can do, but they can also now run the things a YouTuber can do. Gain new subscriber. Yay, new subscriber for your channel, Matt Heaney Apps. However, just like with the properties, anyone who is of type person hasn't got this method because they're not a YouTuber. So person2, who is J of type person, cannot gain a new subscriber because they're not a YouTuber. Okay, so hopefully you can see the point I'm making. Because YouTuber inherits from person, anyone who's a YouTuber would have everything a person has and everything in the YouTuber class. So in this class, we effectively have all of this and everything in person, because YouTuber is a person. There's an is a relationship between YouTuber and person. They are a YouTuber, but anyone who is a YouTuber is a person also. However, anyone who's a person does not get any of these extra properties or methods, because they don't need them because they're not a YouTuber. So YouTuber builds upon person without affecting the base person class. And that's why inheritance can be so powerful, because we can take an existing class, so an existing object or item or thing, and we can build upon it. And we can just keep inheriting down. You could inherit from YouTuber, and then whatever that class would be, you could inherit from that. And you could just keep working down and down and down, building up these items. But the golden rule to remember, if you inherit from something, initialize your way back up the list. So, YouTuber inherits from person. We have to set up everything this person would need to be a YouTuber and also set up everything they would need to be a person. If you inherited from YouTuber in another class, you would take care of all that other class's properties and then initialize YouTuber, which has to take care of these properties and the properties in person. So when you inherit, take care of the properties in that class, but also remember to take care of all of the properties that you're inheriting. One of the really powerful things about inheritance is that not only can we inherit from these custom classes that we built ourselves, like person, but we can also inherit from ready-made classes in Xcode. So for example, if you've ever used SpriteKit, you will know all about SK Sprite nodes, the images in your game. You can set up a brand new class and inherit from SK Sprite node and build a new object. So for example, you could have a boss class. This would have everything an SK Sprite node has, such as position and size, but it can also have new properties like health and how many lives they have, for example. It's very powerful. So when we inherit, we get all of the properties, but we also get all of the methods, which by default will run in the same way as the class we inherit from. So for example, YouTuber1 can run celebrate birthday in the exact same way a person can, and it would do the exact same thing that it would do for a person. However, sometimes we want to do something a little bit different if we run this method on a YouTuber. So at the moment, a YouTuber who celebrates a birthday would do the exact same thing that any person would do when they celebrate their birthday. We add 1 to their age and we print a message. But what if we wanted a YouTuber to do something a little bit different when they celebrated their birthday? Well, what we want to do, we want to take this method and we want to override it. So, what does that mean? Well, in the YouTuber class, make sure you're outside of any other methods. We will type in the name of our method that we want to override. Celebrate birthday. And straight away you can see Xcode autofills override for us. So what that means is, if we run celebrate birthday on a YouTuber, do this instead of this. So if we don't override, a YouTuber can still do this because they inherit from person. But if we do override, if we try and run that method on a YouTuber, they would do this instead. And a person would still run the standard version of celebrate birthday. Because remember, this is not being affected in any way. So for a YouTuber, we still want to add 1 to their age, but we want a slightly different message to print. We will print a message that says, happy birthday, and then their name. How about making a vlog of the day for your channel, and then whatever their channel name is. So now, if we run celebrate birthday on a person, they would get the standard implementation of this method. And that would have also been the case if we run this on YouTuber. But now we are overriding celebrate birthday. So if we take a look at YouTuber 1.celebrate birthday, instead of doing what a person would do, we are doing what a YouTuber should do for this method, where we are printing our YouTuber message. So we are overriding this method and doing this for a YouTuber instead of what a person would do. So there's one last thing that I want to show you that we can do with inheritance, and that is something called polymorphism. With polymorphism, what we can do is use different types in slightly different ways depending on the context. I want to make an array, a list of all the people that I included in this playground. There's 3 people. There is Sarah, Jay, and myself. Now we know an array is an ordered list and everything in that list must have the same type. So we learned that way back when, earlier in this series, yeah? So how can we do that? These are 2 different types. Sarah and Jay are of type person and myself is of type YouTuber. But remember, YouTuber inherits from person, therefore anyone who is a YouTuber also is a person. So what we can do, we can make a list called people in this tutorial of type an array of people. So an array for objects of type person. And this would equal person 1 of type person 2 of type person as well. So these both fit. But we can also include YouTuber 1, which remember is of type YouTuber. This will not give us any errors. So how is this working? This is not a person, this is a YouTuber. Well, with polymorphism, this can change type depending on the context. Because we know person 1 and person 2 are both of type person. They're both people. YouTuber 1 is of type YouTuber, but is also a person. So in this usage here, we can use YouTuber 1 as a person because the context wants it to be a person. So normally this would be a YouTuber, but because a YouTuber is still a person, we can include it on a list of people, and in this usage, it would use YouTuber 1 as a person. So this is index 2 on our array. So people in this tutorial, index 2, and as in this usage, it's being treated as a person. When we get it from this list, we can only use it as a person, so we can only get access to everything a person would have, and not the things that a YouTuber has, because for this usage, it's being treated as a person because of that context. However, it will still remain a YouTuber. So with polymorphism, it can change its type for a usage depending on the context, but only for that usage there. Okay, so inheritance is a very powerful tool to use when it comes to classes. So that was our look at inheritance, and that wraps up our look at classes and wraps up this entire series. We have now covered all of the basics of Swift 3, and you should hopefully now be in a position where you can build up and learn about more intermediate and advanced areas of Swift. So as always, thank you very much for watching this video and the entire series, and I really hope you enjoyed these videos and found them useful. Leave any questions down in the comments, hit like, hit subscribe, and I will see you next time. Goodbye.